So, okay, I think that we can start now. It's 3:30. Can everybody understand me? Hopefully, yes. So, Victor, yes, we can hear and see your presentation. Okay, good. And I think that we can start. So, I would say, yeah, hi, and witam a moje sesji. That's the only thing I can speak in Polish language. So, I hope that you understand that I will switch over to English. So, my topic for today is about partitioning as a feature in, for example, here with SQL Server, which may help you to solve different workloads when you're dealing with big data or with fast data coming in. So this is the topic here for the next 45 minutes. You don't see very much slides. Everything is purely demo-based. The topic is optimize your data workloads and your data management. Due to the fact that we have the time constraint of only 45 minutes, thank you, Victor. Okay, so due to the time constraint, what we have, I just only want to show 2 of the 4 different scenarios I normally present. So a few words about the replay. If you want to play this session and you have SQL Server running, these are the links for the databases I'm using. I have a quite big one. This is the ERP demo database, which is around 16 gigs. And the customer orders, and that is what I'm playing with, because then the partitioning work quite fast. And if you want to have these slide decks and the demos, just follow these links here for partitioning for data management, and then you will automatically have the links for the databases. Just a few words about me. Forget about the commercials right on the left side. Just only most important thing here is my email address. So if you have any questions concerning this session, or you have any questions concerning the engine or partitioning itself, feel free to drop me an email, and I promise I will answer you. Maybe it will take up to the upcoming weekend. One important note. All the use cases, what I describe here, where partitioning helps dramatically to speed up the system, are real-world scenarios. So in my working lifetime, I would say, this is over 30 years, I have visited lots of customers, and a few of them were dealing with extreme problems when they have big workloads with huge amount of simple single small transactions, and for example, DBAs when they are dealing with big databases. And these are the 2 scenarios I want to show you. All these scenarios, what I want to show you, are very, very hard simplified for this session. They were way more complex, but it should give you an idea about what you can use partitioning for. And one extra note to this, whether you're using SQL Server or Postgres or Oracle, I think in all RDBMS systems, you can deal perfectly with partitioning. So here is the first use case for partitioning, and that was a quite interesting thing. My customer is a pharmaceutical company that is producing drugs on various production lines. In my demo here, I have 16 different production lines. And one of the biggest challenges for this scenario was that whenever a product has been created, it was going through a so-called Q&A check. They were checking the consistency, the weight, the size, everything. And all these information, the quality check, has been stored in a SQL Server database. And one of the problems here was that the infrastructure was, from their opinion, absolutely perfect design, but there was a problem in it. What you can see here is that we have 16 machines here in our demonstration. In there, it was way more. And all these physical machines, production machines, are connected to a web server. And when the Q&A process was working, the data were sent to the web server. And the web server was taking them, grabbing them from a queue, and then pushing them into a database. The problem here was that after a very short time, let's say 30, 40, 50 minutes, suddenly we saw that the web server, or that the queues on the web server, were filling dramatically. And that was the point where we saw that the data were not able to be pushed quite fast into the database. The SQL Server they had were on a big machine. They had incredible fast storage, but the amount of data they were sending to the SQL Server with these lots of different threads, that was way too much for the SQL Server. And so one of the problems they had was the problem with the design of the tables where they stored the Q&A results. What you can see here is a machine ID, which represents the production machine. Then you will see a date, when was this Q&A happen, and the column C1 where we store this information. So the data in the queues grew because SQL Server could not save the data quickly enough. And what was the problem here? To understand these problems, you need to understand a little bit about the internal structure of SQL Server or of a database. Whenever you push data into a table, SQL Server requires space for this. And therefore, SQL Server, in this case, SQL Server, will try to set a so-called exclusive lock on the resource. And if too much processes are doing exactly the same, then they have to queue. So this is called Latch Contention, because this wait stat for this problem is called page latch exclusive. So this Latch Contention was the problem because the database design was not able to scale. Think about the system, how it works. When we have an index on the machine ID and on the date, and exactly in this order. So the machine ID first, and then the date. Then we have a problem with the insert statement, because with every single thread, a different machine ID appears and wants to get inserted into the table. And not only the row gets inserted into the table, but it could be that the page where the data gets stored is full, and then SQL Server produces a so-called page split. And this was one of the problems we had here. So let's see how we resolve this issue. Therefore, I go over into my demo environment, and sorry, this is the wrong one, sorry. But here we come with this. So this script will go with you step by step through, that you can understand what in detail we are doing. First of all, I create my demo database. So this is just only a simple database, no special things, just only one database file. Here I create my table, which is for the Q&A information, and you can see the machine ID, then the timestamp, and you see this column which stores the Q&A data. So then I create exactly the same clustered index on this table, which is here on the machine ID and on the date column. And this here is a very primitive and simple store procedure, which is doing a very primitive job. It just takes, or I hand over a machine ID, say, please push the data for this machine, and then I try to push as much data as possible for this dedicated machine into the table. So what I then have here is an extended event. You see this here. Let me refresh this. And this one is for the high transactional workload. This extended event will log every single time when we have to wait for a so-called latch. Okay, this is up and running. I clear my statistics. And what I'm now doing is I'm simulating the system with what the customer has. In the Microsoft world, we have a tool, a very cool tool for this, and this one is called O-Stress. And this O-Stress tool that can simulate simultaneously processes that you can test your workloads. I can strongly recommend that you will, if you're dealing with this, you should use this. Let's first of all insert it here and let me shortly explain what it will do. What I'm doing is very simple. I am executing a batch file, workload number one.bat. And if we look into this, let's see, it's very simple. I start 16 processes here. See this here, 16. And I start now 16 times the OSTRES program. I connect to my server, and then I execute this stored procedure. And the machine ID for every single process is a different one. So from 1 to 16. I say, please execute this in my database I have created before. And I want to insert 10,000 rows per each machine. This is in a silent mode that I don't see anything here. And this is just only for the recording. So this batch file now gets started. And while this is running, 1, 2, 3, go for this. So now we are starting this and doing some power or some heavy workload on the system. And what you see here is that SQL Server now is waiting. The wait type describes for what is SQL Server waiting. So here you see, unfortunately, only write block. So that means we all are waiting to transfer the data to the storage. And what we can't see here is what happens in the background. So now it is finished. And have a look to this. And this is important. So for entering 10,000 rows, this process was taking 26 seconds. To be honest, this is a very, very high value. 27 seconds. And what we see here is that we are growing. So the consuming time is growing and growing and growing. So it takes longer and longer. And the reason for this is that that we were waiting for the resources. And what we can see here is for what is SQL Server waiting. And we had some CPU issues. That's okay, because I just only have an 8-core machine. Primarily, SQL Server was waiting for the write log wait, but we had this so-called page latch or the latch contention. And this was nearby 0.5% of the total waiting time of the extracted waiting time. The reason for this is, and the performance, by the way, for the table was really decreasing dramatically, is that now SQL Server had a high fragmentation in the table. Fragmentation does mean that now when SQL Server is reading data, it has to skip pages, go to the next, because there was a split in between. SQL Server mostly tries to achieve that we allocate pages after pages so that we have it in one row together, that we can speed up the reading of the data. But here we can see that we have now 22,000 data pages, and the fragmentation, this is definitely a big problem. We see here that we have a fragmentation of 99%. So that means that nearby every single data page is not connected to the right one, to the next one. So SQL Server had to jump all the time. The reason was, as I said, that the system was, when it was filling up the table, it always had to push the data in between. So let's say you have a record for the machine number 1, and immediately after it, there was a record for the machine number 2 in the data page, and the data page is full. Then the next record with the machine number 1 wants to enter in between this. And this is required. So what will SQL Server then do is say, oh, sorry, we do not have much space on the data page, so grab the half of it, push it at the end of the table, and then you can fill in, because then we have enough space. And that is expensive. And that is one of the reasons why we were waiting so long for this write block and for the page latch, for the latch contention. So when we think about the design, then we can quite fast see that we have a problem with scaling. And the scaling is due to the fact that when you look to this one here, that SQL Server wants to insert all the data permanently into one big data file. So what we can do is think about this, that we say, well, come on, every single machine, or let's create for every single machine a dedicated file. So if we do this and we then push the data into the database, then SQL Server knows automatically to what file it has to write due to the partitioning function. And another big goodie here is that when we have, for example, different machines with different workloads, we suddenly can scale the system by adding more files to the file group where SQL Server inserted the data. So let's see how this is working. I will do now the following. I truncate my table. One moment. Let me show you something more. One moment. Here. Yeah, okay. What I want to show you is, because you know I have recorded everything what happened, let me show you how often SQL Server was dealing with page splits. And you will see now, so SQL Server is reading the recordings, and you can see here that we had 21,000 so-called page splits. And whenever the split jump is higher than 1, that means that SQL Server will not go from one page to the next one, then we are talking about a so-called bad page split. And this is exactly what happens here. And you see how much of them we have here, where SQL Server was always entering data at the end of the table while it was pushing data into the middle of the logical structure. So this is something what we want to avoid. I stop this here, this session, for one simple reason. I delete now the recording because I want to do this new. Here it is. We delete this. Okay. And then I start the session again, that it goes in the background, and we can see what happens now. So what will I do now? When we are talking about partitioning, and this is my expectation here that you understand a little bit of it, what we will do now is the following. I want to take my table, or first of all, my database, and change the underlying physical structure. The physical structure is actually based on one single data file. I think, because we are talking about big data here in this line, that you all know when you're dealing with data warehouses, it is a common approach to have more files to write into, because then you can speed up the writing performance. So that is what I want to do here. And I do it in single steps, and every single step I show you the different results. First of all, have a look to the database, how it looks now. You see here that my database only have one single data file. This here is my log file. Forget about this, not so important here, but I just only have one single data file. So all 16 machines were pushing the data into this single file. And you can understand why this cannot scale. So what I'm doing now is, in the first step, I now create 16 file groups. So that goes very fast. And when I now have a look to my database, as I said, this is the physical layer here. You can now see that I will have here, this is my original database file. And then for every single machine, I created a new file, and have a look to this one, the file group. I placed it on a separate file group. The file group is the glue between the logical file name and the physical file name. So you see here, the machine number 1 will write into this database file. This one here is the physical file. And you see also every file had the same size, the same growing. And now we have the physical layer finished here. The next step, we are now dealing with the logical implementation of the partitioning. And I do not know how other RDBMS systems are doing this, but basically we need to have a so-called partition function. And this partition function will have one value for every single machine here in this case. So what I'm doing now is I'm providing SQL Server a function where SQL Server later on will know where to write the data to. Every single data will go through this partition function. And here, the next step is now that I create a so-called partition schema. And the partition schema does mean that we have, let's say, a logical name for the physical infrastructure of the database. The schema, for example, here in this case, does mean when I place a table on this partition schema, then the underlying infrastructure is dealing with these file groups. So SQL Server now knows that these file groups from machine 1 to 16 plus an additional one belong to this partition schema. So I create this. That's done. And the next step then is that I first need to drop my index, because actually my index is on just only one file group. And here you see how now SQL Server will implement the partitioning strategy. Okay, yeah. So I now create my unique clustered index based on the machine ID. So this is the first order criteria, and the date time, or the timestamp, is the second one. And I say to SQL Server, hey, come on, if someone is inserting data into this table and you can assign the machine ID to an underlying file group, then write it into this file group. If not, write it to the primary. And this is based on this machine ID. So this is the indicator for the part where we should write it to. And when we look to this is now the implementation. So this is the logical implementation. You see here, this is the table, the clustered index. This is the name. And actually, we do not have rows in it, but we have partitions. This is my partition function. And we can see here what is the underlying file group for this. This is just only for a cross-check. Now, I delete all my weight statistics. And then, yeah, that is what I did before. I restart my session, make sure that no file is available. This is the latest one. Okay, this is okay. And now we can start this again. Before I do this, let me start the resource monitor. I'm sorry that it is in German, but yeah, this is unfortunately how it is. Okay, so now let's start again the workload. And remember that we were taking around 26 to 28 seconds. And when I start this again, go for this, and let's see what's going on here. Here is my SQL Server, and I hope that it will display the data. But you can see here that SQL Server is writing with 24 megabytes now. We are hitting here 16 different processes, and all this, unfortunately, doesn't show it here. I don't know why. It's a problem with the resource monitor. But normally you should see here that we are writing in 16 different files. So, okay, you see that we are faster, around 10% faster here, because the first one was 26, but now we are 24 seconds. So, and the last one was 28 seconds, and now we are at 26 seconds. So we wrote 2 seconds faster for every single process. And in total, with 16 simultaneous processes, this is at 30 seconds we have saved here. And this is something what we need to prove. When I look to the weight stats here, you can see here that we do not have any page latches anymore. Yeah, so we have the write lock, which is absolutely okay, really okay. But one thing is quite important here. You see that the percentage of the weights for writing into the transaction log is way higher than it was before. So what does this mean? We had more. We were finished in less time, but all of the time, or 97% of the time, we were only waiting to push the data into the log file. That's it. But no more contention where we have to wait to get a lock on a resource. And this is a really impressive point. The question here is coming up, why was it now faster? The reason is, when we have a look to the index, to the physical index, look at this. Please have a look to the fragmentation. And you can see now that we do not have any more fragmentation. The question is, why can this happen? The reason is very simple. Due to the structure of the table, let me do this, let me show this here again. We're going up here. We have an index on the machine ID and the timestamp column here. So the reason why we do not have any more page splits is very simple. Every single machine is now writing into its own database file, and we have a so-called ascending key. So that means that every single record we insert into this partition is an increasing value, and that does mean that we write at the very end of this portion of the index. And this makes the fragmentation so incredibly slow. And I can prove it by evidence. You remember here, this is the result. We had 21,000 bad page splits. Now with the partitioning, we have only a few of them, maybe none. This is the result. So instead of 21,000 bad page splits, we now have only 7. And this is the reason why the partitioning here at that customer was helping so much. So after this, we saw that the system was scaling pretty well. And what the next benefit for this customer was at that moment that we could say, well, no problem. If you see you have a new machine, let's increase or give another partition. And if you have a machine which has a higher workload, excuse me, then we just add another file to the same partition that we can write into multiple files. Incredible fast. So the customer was more than happy with this. So this was the first use case. Due to lack of time, I just only have another 15 minutes. I cannot show the next two, but I want to explain very shortly what we did there. This is a customer based on a retail business, and it is in Europe one of the biggest retail company. It has hundreds of thousands of supermarkets all over in Europe. And one of the key points what they had to do was they had to create reliable plans for supplying to the stores. And what they did was every night at 10 p.m., automatically the cache desks were downloading their whole activity over the whole day into CSV files, and then they were loading into a data warehouse where they then gets analyzed, and the stores were then, or the plan for the supplying then was calculated, and the problem was that they needed to finish at 3 o'clock in the morning because the first trucks were leaving at 4. And the biggest problem they had days where the workload was not finished at 6. So they had a delay of 2 hours, and that was incredible. We solved it with partitioning. So I will skip this here, and I will go immediately to the management of big databases. And believe me, exactly at that point, you will have a super great benefit of partitioning. And this is what I want to demonstrate to you. When you see nowadays how big databases are, when I remember back when I was starting my career as a database administrator in a bank in Frankfurt, the databases were very small. Okay, not Oracle, but the SQL databases were really small. Let's say if they were 3, 4, 5, 600 gigabytes maximum. The rest was really small databases. So when it then came to restores in case of an accident, they were really quick recovered, and everything worked well. But nowadays, for example, I have one customer here in Germany who is supporting around 15 terabyte big data, 15 terabytes. And when they do a restore of it, it takes around 6 or 7 hours for the restore for 15 terabytes. One of the biggest problems is that the management say, sorry guys, this is not working for us because we need to do our marketing strategies and we must have the so-called hot data within 60 minutes. That was their SLA, service level agreement. When we're talking about SLAs, we have 3 points, but the last one is not so important here, but we have the recovery point objective. For a data warehouse, quite difficult. And we have the RTO, so the recovery time objective. And the recovery time objective is, for this particular customer, the critical point here. So when we're dealing with big databases, you have to ask yourself a few questions. Point first, is it required to back up the complete database really every night? I see customers doing that. That's incredible. How long does this backup take? How much storage do you consume? Will differential backups help maybe? Why not running backup against hot and changing data? So if you have a 15 terabyte database and the hot data is just only, let's say, 800 gigabyte, it would be so perfect if we just could say, come on, restore the hot data, and then when this one is done, we can grab a coffee, sit down and say, okay, now I can start with the older data. This is the demo I want to show to you. The same question as you have for a backup is exactly the restore. And partitioning, believe me, it can boost the restore by restoring only read-write file groups. Restore the read-only file groups later. So, and this is how this is working. What I'm doing now is I'm creating a database. Okay, it's not 16 terabytes, but I have for every single year the millions of rows into a dedicated database file. And then I will mark the old data, which are definitely not will change anymore, as read only. And you see here that only the last two are the one which are active. And now let's see how this will work in reality. Oh yeah, that's the timing is perfect. So this is it. So what I'm doing, I go step by step with you together through this demo. The first step, I create my demo database. This is very small, it's only a demo, but then I now create in my demo database a big table with 3 million rows. And these 3 million orders are distributed over 19 years. And what I'm doing here is I now create, again, a partitioning function, and you can see here that now I don't take a machine ID or anything like this. This time I'm taking dates, and you can see that it starts in the year 2000 and it ends in the year 2019. Okay, so this is only the logical layer, and when I have the logical layer, I now need the physical layer. And again, I'm doing exactly the same as I did before with the problem with the pharmaceutical company. I now make my demo database from the physical side that I distribute 20 different files. Done. And when we have a look to this, you can see now in the files, look to this. Here are my orders from 2000, 2001, 2, 3, and so on and so on. This is my dedicated file group, and these are my files. So now I create the partition schema. I need this partition schema, you remember, to connect the logical partitioning with the physical layer. So I say that I have a schema which is connected to these file groups here. And then I move my table to this partition. The moment I do it in this way, I say create a unique clustered index, and you see here my ID and my order date. So the order date, this is the one which is responsible for the distribution of the data. Takes a little bit, and we can now see, I hope that we can now see, yeah, here it is. So now my table customer orders will have a clustered index. You can see here, again, the same, we have different partitions, and you can see what is the maximum value which gets stored in this single partition. So, and now the database is up and running. Actually, all my file groups, really all my file groups are read and write. And that does mean my database is running, by the way, in a simple recovery model. And what is happening now? Well, if now an accident will happen and I need to restore the database, I can only restore the whole database in one single restore command. But the policy in this company was that they said we only must be able to change data maximum 2 years back. So what I'm doing is I'm marking all the other file groups. You see here at the stop 2018. And now I set the different file groups as read only. And here, this is the result. So the year 2000 read only, and so on and so on. And you can see that only the last one, the 18 and the 19, these are read and write. So that means these both partitions here are the hot data of my customer. Now I run a backup of it, and I replay a big crash. So I do a backup. Done. This is something what we are doing every night. And now I drop my database. Something what we are all afraid of, especially when we come in the morning back to our desk and we see there is a problem with the database. I've seen lots of well-experienced DBA, and they were sweating in the moment they opened their laptop and see, oh my goodness, there is a problem with the database, which I need to restore. So here comes the first step. I want to measure how long will it take to restore the complete database. We go for this. So I have flash storage, but you can see here, it was taking 2 seconds. Now think about this. This should be, let's say, 20 hours. The database is way larger. And you can see what SQL Server is doing. SQL Server is restoring every single file group down, and you can see that it was taking 1.3 seconds. We had a throughput of 400 megabytes. So this is something what the business say, sorry guys, this is not acceptable. We want to have it faster. Keep in mind, we are not interested in the old data. We just only want to have the 18 and the 19. Well, and now you can be, as a DBA, so relaxed. The only thing what you say here is, make a restore of my demo database, but please only do the read or restore only the read-write file groups. With partial, that means that SQL Server will hold it open for applying later restores. And this is important for recovery. And this is something what is absolutely crucial, because what's going on now, and this is that SQL Server now let my database run in an online. It's a little bit slow, actually. I think it's because of the huge amount of CPU what the system is consuming. One moment. So my database is operational. And look to this. You see here that SQL Server now had the demo. So these both database files online. This is my primary. This is my log file. And you see here, the recovery is pending. So that means that we are waiting on it. And the other two are online. So now I can give a call to my customer and say, hey, guys, your hot data are online now. You can work with this. And they say, no, that cannot be. That's impossible. Give it a try. Well, here, what they are doing. I run a query and it's running. Yeah. So now they can run their analytics. And this is something what is absolutely perfect. But here comes one big point. One thing must be very, very clear to the business. They cannot, or other words, whenever they are running queries against the data, they always, really always have to use the partition key. So when I run this query, this won't work. So when I just look for the customer ID number 10, it's clear that SQL Server will fail because it is now looking, or it wants to look in every single partition, because we did not say, hey, sorry, only in the hot data. And this cannot work. So as long as you do not cover the partition boundaries, an update won't work. Here it is working. Why is it working? Well, very simple. Because we say the order number must be in this partition. Then it works. So now, after we gave the call to our customer, we now can relax and say, okay, sir, one moment. While you are working, I just restore the rest of your database. And you can see now that SQL Server is restoring one file group after another. For me, to be honest, it's not a problem that it takes a lot of time, because my customers are working with their active data. And in the meantime, I can now restore all the rest. And that makes it so incredibly comfortable when you're dealing with partitioning. So you see, it's 45 minutes done. I hope that what you have seen, that you enjoyed it, and that you now see that partitioning can help you as a developer the same way as a DBA. Dziękuję bardzo for having me here for this great conference. And I really, really hope that we can meet any other time, maybe next year in Poznan, face to face. Dziękuję bardzo i do widzenia.